Hey guys, so I'm just hanging out in my office, which is covered with cat-related items. I don't know if you can see them. Yeah, there's cats everywhere. Um, and we're going to go ahead and just quickly look at a very simple regression analysis in StatCrunch and see what that's all about. So I'm going to hide myself. Don't want to look at me anymore. So this data set, which I just randomly found perusing through StatCrunch, so I have no idea of its validity or anything like that, shows high school GPA, math SAT scores, verbal SAT scores, and then I'm not really sure what the comp GPA is, but it has students' university GPAs. So the goal here for us is to try to use some of that application data that you might have if you're applying to a university, high school GPA, math SAT, and verbal SAT, and see really how much we can find out about your university GPA using those three, which one is going to give us the best prediction, and just look at how all of this linear regression stuff is actually done using technology rather than just sort of here's the answer, let's go, that we do in class. So first thing we want to do, let's just say we're looking at high school GPA and want to see how much does your high school GPA predict or influence your university GPA. First thing we want to do is just a quick scatter plot, right? We have two quantitative measures. We'd like to visually see how much they're related. So high school GPA would be our predictor. Our response would be university GPA. No reason to do any grouping, but if we had something like major or, I don't know, gender, we might want to group by that, which we could change the color so we could see if there's any group effects. But for now, that's all we need. So I'm just going to go ahead and press compute. So here is our corresponding scatter plot. What we see looks to be fairly linear, right? We've got a nice linear positive relationship. We do have what Kaylin had said in the first class. We do have some issues here where in the higher GPAs for high school, we're doing a very good job of predicting people's university GPAs. But in the lower GPAs, we're starting to see a lot more spread away from that trend. So this fanning is an issue for us and would mean that simple linear regression is probably not the best bet, but we're going to go ahead and try that anyways because, well, it's intrastats and we don't really have any other options. So let's go ahead. After we did scatter plots, we also did a numeric measure. We did correlation. So I'm going to go ahead and do a correlation just to show you how to do that in StatCrunch. So it's a summary statistic correlation. And unfortunately, without my keyboard, it's very hard for me to grab only certain things. So I'm going to grab the correlations for everything. And we'll just see what that looks like. So this little matrix basically shows us for high school versus university, our correlation is 0.78. So we have a strong, just on that edge, a strong positive linear relationship between our high school GPA and our university GPA. This slightly drops off when we get to the math SAT score. It drops to a 0.66, so only moderate, and then verbal is 0.65, still moderate, still all positive, which we hopefully expected. The better you do on the SATs, in theory, is supposed to predict that you're going to do better in college. That's why they use this on applications. We can also see some of the relationships between our GPA and our high school GPA and those other SATs and the two SATs to each other. I'm going to ignore this last row here of comp GPA because I really still don't know what that means. It is very highly correlated with the university GPA, so not sure where it comes from, but probably some version of that. So correlation is looking good. Our graph was looking good minus that fanning. So let's go ahead and perform some linear regression. So back to stat. Halfway down we have regression, and we want to do simple linear regression. We have a single x and a single y. This is all we're going to do in intrastats. So single x, we're going to use high school GPA. And for our single y, we are going to use university GPA. And then we can go ahead and compute this. So we have our entire line. If you had somehow a 0 in high school as your GPA, we predict your university GPA to be a 1.1. And then for every 1 point your high school GPA increases, your university GPA would increase by 0.67. So that will be the relationship. You could use this to make predictions on your own university GPA for once you transfer based on your high school GPA. Though again, we have no idea how good this data is, whether it was transfer students, whether, and transfer students may have a different relationship. We also are told here that our correlation coefficient, our little r, I didn't have to do that separately. We could have just grabbed it from our simple linear regression. And we have our r squared, which is literally just that value squared. This tells us that we can explain about 61% of your university GPA just looking at high school GPA, right? Just looking at someone's high school GPA gives us 61% of the information about how they're going to do in college, according to this data. So that's probably our biggest predictor. We could go ahead if we wanted to, and if I pressed over, you can actually see that fitted line. Perfect. If you wanted to tag some people as potentially being outliers, the nice thing about StatCrunch is you can actually click on the graph and turn them pink. And then if you wanted to, you could actually scroll down through your data set to figure out where those unusual people were. In this case, somebody who scored really poorly in college and fairly poorly in high school versus someone who did terribly in high school but then pulled it together for college here. But those are just things that you're able to do in StatCrunch. If we wanted to, we could redo this data, redo this work, redo our regression with one of the SAT measures instead. So we could use like math SAT with our university GPA. You can see here we're going to drop in our r squared just a little bit. We went from a 61 to a 44% r squared. So in this case, your high school GPA is going to be the best predictor. And we knew that as soon as we saw the correlations. The highest correlation was between high school GPA and university GPA. So that is sort of an overview. This does not mean this is the only thing you can do. We could also, if we had wanted to, done a multiple linear regression where we could say, okay, I realize that all three of these things, all three of them could influence your university GPA. So let's put them all into our model and see what happens. If you do something like this, the output is not nearly as nice, but you can see the only thing I really care about here is our r squared. And that r squared, it only went from a 61 to a 62. So we did not add much more information by throwing SAT in along with the high school GPA. The high school GPA is telling us everything we need to know. We don't need to look at SAT. And this is kind of one of the arguments that we're making at Mesa, or that's being made across California, is that those placement tests that choose where you're going to go in math do not actually tell as much about your math ability as just looking at your high school GPA. There are a lot of pilots where now they just look at high school GPA and throw students with a GPA over a certain amount into statistics because they know they'll be able to figure it out. So this was just a quick intro to linear regression with some hopefully more realistic data than some of the stuff we might have seen. Oops. So I hope that was not too painful. I'm just moving around stuff. I'm not trying to. Okay, this is over. I'm just stopping it right now. Bye, guys.